A very good morning once again. So we will be starting our first session of the day by Thiruvananthapuram chapter. So the topic of the session would be blockchain, new use cases. Abhilash would be giving us more insights on this particular topic. He works as a solution architect at 6D Technologies. I would welcome Abhilash onto the webcam and microphone. Over to you, Abhilash.
Okay, right. Thank you, Navina. Good morning, all. Okay. People. Very good morning to all of you. So, I'm happy to be here speaking on a few minutes on the blockchain, especially on the new use cases. Just a small FYI or a bit of apology. This is more about a theory chapter of blockchain. However, when it comes to implementation, I'm still doing some beta. Hopefully next quarter or by the next 6 months, I should be able to be up. Okay, so what I am going to speak is on blockchain. I hope the audience that we have is from our IT industry. So since most of the people are from IT industry, they would have heard of blockchain. So in today, I'm going to speak a little on blockchain, the use cases of blockchain. But again, I'm not sharing anything of implementation. It's more related to the use case and how the underlying technology of the blockchain is and how it works for the software systems. So I'm sharing you what I'm going to speak for the next few minutes. So as you all know, blockchain is though one of the underrated or the dark horse for this IT sector. It is expected that the blockchain will be used widely in this IT industry. And I want to introduce few use cases of the blockchain industry. And once I introduce the use cases, I will move a bit into the underlying technology aspect of the blockchain. So many people who are aware that the blockchain has some traditional use cases, that like 3 or 4 years back when blockchain was being mooted, there were few use cases that was being mooted as the reason why we need blockchain in the industry. However, as the time progresses, we have found new use case which is more relevant to what business we are doing, and it involves individual and their personal data. For example, we have the new use case called blockchain in identity. Sorry. Blockchain in identity is that new use case I want to spend a few minutes. After that, I would speak on what blockchain is, a bit of the predecessor to blockchain, that is a Bitcoin. The mechanism underlying Bitcoin is DLT, distributed ledger technologies, and few blockchains based on classifications. Okay, so when blockchain was being mooted, there were few reasons why blockchain was being mooted by the industry's heavyweights, especially that blockchain was first adopted by the financial sector. So there is a very specific reason, or what I believe the reason is. The underlying mechanism of blockchain is distributed ledger technologies, and there was some question. The underlying technology for blockchain is distributed ledger technologies, and the system that first proved that a distributed ledger technology, DLT, could be used widely was Bitcoin. Bitcoin, though, was launched some 2009. Few years later, people got serious by 2013-14, and it started really helping people when they wanted to transfer money from person A to person B. And that's the main purpose of the Bitcoin, and it helped people to transfer money from individual A to individual B. It doesn't matter where the individuals are responding. Like I could transfer money to a person who's just staying in my own locality, just half a mile away, or I could transfer the money to a person who's staying in Australia. It's far off, other continent, but it doesn't matter. Yeah, both in 20 to 30 minutes, he will get the money. So moment Bitcoin started working on financial transactions. It's the financial sector that picked up this subject first, and they decided that we need to do something, and they investigated and came up with various solutions. So IBM has offered a platform called as WorldWire. So wire means it's the same thing that they normally do, wire money, wire transfer money. Earlier also people used to do wire transfer money, but this time they decided that we will help people to transfer money using a bank, using a regulatory mechanism, yet it will take far lesser time. Example, if I want to transfer money from here to Australia, what I will do is I will go into my bank, let's say a federal bank in Kerala. I make the transfer, online request I raise and detect the money. The bank would move that money to its regional headquarters with an AML, anti-money laundering, and then it goes to the central bank. Central bank will verify it, and I did so from a couple of checks at federal bank, couple of or one or two checks at central bank, and that is the RBI. From central bank, it will move to another central bank in Australia, and then it will go down to that bank and ultimately the branch in Australia. So 2 to 3 days is easily taken. We tried it in the last 2 years back itself, and it took 2 to 3 days itself. With WorldWire, we are bringing it down to less than 30 minutes, with ensuring that all regulatory mechanisms are available. Similarly, another use case that was noted initially was the food trust. It's more the food trust is more about the supply side of it. A supply chain mechanism, which is one of the first use case for blockchain, especially the supply chain in food industry or the supply chain in normal manufacturing industry, saying supplying does the manufacturing of a component, it goes to the shipping goes to the nearest port, from the port it goes to another vehicle, and another vehicle takes it to another location, and then move it to a port, and then bring it in road again, and then move it to a destination. So a lot of legalities and processes needs to be followed. Similarly, in case of food trust, there was a need for that people have to work more to speak on the food trust chain. Let's see these use cases a bit more. So the image that I'm sharing on my left side is about the traditional way of doing a payment system. Here, a person is sending money to Laura, Adam is sending money to Laura, and it takes lots of checks and balances, and it takes 2 to 3 days. While if there is a blockchain, and you don't have to worry too much because the underlying data structure is same, which is shared between all parties, and hence the money transfer is faster. Now, this is the food trust, and I have picked this image from Snapper Bus, which is a website meant for this particular web purpose. What we are seeing is today there is a trend for organic products, organic food, whether it's a shrimp or whether it's a cabbage or spinach. If people are willing to pay more if it is organic, saying it's healthy. Though there are many products which they say they are organic, but let's say how to convince the customer using software that this is indeed organic. The way it works is IBM has built a network called Food Trust, which is they call as Food Trust, and allow farmers or growers to join the network. Somebody who processes the food also joins the network. If any manufacturing is there, he's also network. He joins the network. The local regulator, he also joins the network. Shipped, it is retailed, and then a consumer. The logic is they all share the same network. They all have the same underlying data structure. So at any point of time, let's say a guy who sells spinach, he puts a load of spinach, moves it to a cold processor, and there is no manufacturing, so he can skip this. Regulatory is updated, it goes to shipping and the retailer and a consumer. Now the consumer is at the store, he picks up his phone and snap and looks the QR code. And at that moment, a provenance is thrown. Provenance means the entire journey of this bunch of spinach from the time it was sown to the climate conditions, to the chemicals it was treated, to the chemicals, the organic manure, or everything info that has been given to that particular block, how it has been moved from grower to processor, and wherever it went, every info will be picked up and shared with the consumer in real quick time or near real time, close to some 30 seconds it will take. So these are one of the initial use cases of blockchain. So I'm not sure if others are able to follow me, if there are any questions. I just want to move to the new use case, which is being noted as a problem solver. This use case is called as a distributed identity. Distributed identity, it does not happen in real world. It happens in the cyberspace or the internet world, where people, machines, and organizations will be given a unique ID, and they will be it's not they will be given, they can acquire a unique ID and provide their unique ID anytime as they want. I am moving to the next slide. Okay, anybody, I hope some of us were aware of this diagram, this cartoon which I picked up from the internet, the New York. So what it says, it's a bit of satire, but says, on the internet nobody knows you are a dog. The purpose is like this. Okay, whether I can say that I am the president of India, nobody bothers, or nobody, it's not bothers people. I can convince people that I am the president of India, but in reality it need not be. So similarly, there are many people who claim to be what they are, but it may not be correct. So this is a serious problem which distributed identity is trying to solve. Identity in the internet. What can I say about identity? Initial days, there were a few web pages of internet. Then by the 90s, identity became very, very strict, saying we introduced the authentication, that is username, password, or the username password existed way back, even in Unix as well as in mainframe. But in internet applications, by 90s, it got the idea of username password came in. For 10-15 years down the line, the identity platforms came up. The identity platforms also relies on the same thing called as a username and password. But then we have a decentralized identity, which is the going taking away this this business of giving username and password at each of our websites. So I'll try to explain that a little here. Okay, this is how the decentralized identity works. Here it is an individual. He is connected to a blockchain, which is the distributed ledger, and here he can go to a peer, which could be a shop, which could be a internet site, and anytime he needs, he would ensure that his identity is kept only to himself. He does not have to go there and create a profile page and create a username and password. So any questions till now, or is it just I'm just speaking and others are?
I think so far so good, Abhilash. We have not received any questions. I think we can take the questions at the end of the session while we move.
Okay. Okay, people who are familiar with blockchain, this is the blockchain. What is a blockchain? This is an open distributed ledger that can record transactions between parties. It is done efficiently in a verifiable and permanent manner. The most important things are marked here. It is done between two parties. Of course, transaction needs at least two parties. It should be done efficiently. It won't be cumbersome. It needs to be done in real time or near real time, in verifiable and in a permanent manner. It's permanent is one of the hallmarks features of blockchain, because blockchain ensures that you can write to a ledger, but you cannot update it. Earlier, like even if you have a user interface where you using your VB or Java, you punch in some details, and that details goes into the database. No, that won't work here any further. Blockchain does not allow you to update. You can only write to the ledger. Okay. These are few other aspects of blockchain which I just picked up. It's a growing list of records called blocks, and they are linked cryptographically. So basically, it's as you can see, the blockchain itself is made of two words. One is a block, another is a chain. We use blocks everywhere, like our residential layouts. There are block 1, block 2, like that. Or what do you say, the law of a block of vehicles or the block. So transactions in IT industry, you can club them together into one block, and there's somebody else would have another block, and that blocks would be linked by each other, similar to a linked list mechanism, very similar, but here we are using cryptography as well. Here, each block contains the cryptographic data of previous block. That's one of the reasons how the block keeps growing, even if it's a public system. It will have the transaction data and timestamp. So I told in this beginning we said that this is a distributed ledger. So I hope most of us are aware of a centralized system and distributed ledger. Like centralized system is the similar way that client server or three-tier architecture where somebody sitting at the client side would punch in the details and it goes to the central machine, which gets the data. You schedule some jobs on top of it, and you get results. However, in distributed system, there are many systems which are linked with each other, and there is no client server or every system has equal rights, and it allows you to work properly in a distributed manner, which irrespective of which node you are, all have equal rights. So hopefully you have heard of few distributed systems that are Torrent and Bitcoin. I just want to spend a few minutes on Bitcoin, like what exactly is Bitcoin and why we needed blockchain. Of course, when Bitcoin was there, some of the use cases of Bitcoin are still relevant today. But then why did we actually need a blockchain though we had Bitcoin? So if you see this first line is about a decentralized digital currency. The Bitcoin is meant for this particular purpose called decentralized digital currency, and it doesn't have a central bank or administrator. They will tell software is going to take care of it. You can send money from person on a peer-to-peer network. And the important thing is Satoshi Nakamoto, the smart person or a group of people, we don't know who they are. They released this in 2009, and it's important that though initially it was released, very few people were aware of it, but over the few years it became popular, and today we have better systems with underlying technology of DLT. So I'm speaking of a very famous or a very popular blockchain called Ethereum, and here I have clubbed of Bitcoin here. Now the point is, why do I need Ethereum or other blockchains when we have Bitcoins? So I'm just putting a few of the points between the differences between Bitcoin and Ethereum, and as I speak on the differences, I will ensure that I'll try to explain why we actually needed Ethereum though we had a Bitcoin. Ethereum is produced by a team of Vitalik and his members. They are Canadian citizens of Russian origin. Vitalik is Canadian citizen of Russian origin. However, Satoshi is not known. Ethereum has better properties than Bitcoin. It is a network software, while the Bitcoin is most use cases of Bitcoin are cryptocurrency with some other use cases. This is Turing complete, the other is not Turing complete. Turing complete means, I believe people in industry or people in teachers, they can say that, yeah, you could simulate the scenario of A, that is given condition A and with a set of instructions and the environment at B. So what output you could produce. So our main important thing is to notice why we actually needed Ethereum though we had Bitcoin. First point is average block time. The average block time in Bitcoin is 10 minutes. So suppose I make a transaction request from A to B. and I submit it there saying I wish to transfer this money from my UTXO unspent transaction account to this, other persons, it will take at least 10 minutes for it to be approved. The reason is the underlying mechanism of Bitcoin says a block can be built only in 10 minutes. So one of the miners would pick up my request, put that in a block, validate it, and if he is successful, then it will go into a blockchain. However, and let's take this example. If I want to purchase an airline ticket and I deduct my money after I select the chair, seat, and the schedule, and I have to wait for 10 minutes. I don't think I would be ready to wait for 10 minutes to know whether the transaction is approved or not, because the software systems have moved forward. Similarly, however, for Ethereum, it is less than that. It is every 15 seconds you can create a block. And if you see, there is a block limitations of 1 megabytes per block. The limitation of 1 megabyte is for the purpose that when cryptocurrency was being launched, you make few records. That is, account A is giving this many bitcoins to account B, and for 10 minutes 1 megabytes per block is more than enough. However, today we are trying to upload images, Excel, and documents along into the network, so the block limitations does not allow us to create new use cases. So clearly there are few enterprise changes or the public new governance systems for which Ethereum is better suited than Bitcoin. Any questions? Okay, I'll speak on distributed ledger technologies. So as I said, there are blocks, they are linked. So this one particular segment is one block, and each block will have a hash of it. Hash is the cryptographic checksum, which is derived from the transactions within the block, and then there is another block, and then there is another block. So each block will have its own hash, as you can see in everywhere, and the previous hash. This hash would be available here. That's the link between these blockchains. And if you see, there is a mechanism called Merkle root. This is how a block would normally look like. If there are some n number of transactions, the current hash is calculated based on Merkle root. I told you that you could verify a transaction in a blockchain. So if I want to get few of the transactions and verify it, you will have to work the entire block. However, if you have the Merkle root, you could actually go to that particular node and find the leaves and verify that the particular transaction did exist. So this helps us to traversing the network without consuming much of the computing power. There is mechanism called consensus. As you see, there is no central or authorizer or a central node which is responsible for blockchain. So what we're saying is we have a consensus mechanism. This is used to achieve reliability of the system. That is, when you don't have people to approve or reject the transactions, you need consensus mechanism. POW is the consensus mechanism that was used in Bitcoin, and few blockchains still uses it, but proof of work has been criticized for being too energy intensive, and it allows every node. There are some close to 6,000 active miners, and if you want to create a block, people would build a hardware and run the mining. So basically there are 5,000 odd miners competing to create a block, which is very expensive. You don't have to do all that. So this problem has been adequately handled in POS. POS is used in Ethereum, where few of the blocks are allowed to create, few of the nodes are allowed to create a block, and they are given nominations. Okay, you run the block. How here, why should I run the block? You will be given some transaction charges. But in the proof of work, the reward was the BTCs. For each block you make, initially it used to be 50 bitcoins were given. After every 4 years, it comes down. So from 50 after 4 years it came to 25 BTCs for each block you produce. Then it came to 12.5 and now it's 6.25 for each blockchain that you make. Practical Byzantine protocol is another important consensus mechanism. This is used mostly in the Hyperledger world, where the idea is if each of us work together, it will exit. It will give us success. While if each of the nodes do not work together, still we can be successful. Okay, so I spoke of peer-to-peer network. That is, there is no centralizing authority. It goes from peer 1 to peer B, peer to peer B. Every node has equal rights. It is handled cryptographically. You saw that hash value is being created. The hash is the rule that prevents people from updating the record via backend using mischief. So even if I go and say that I want to make a transfer of 1 Bitcoin per person, and then I put it saying I'm transferring only 0.1 Bitcoin, it's not possible because the cryptographic checksum will fail. And since the data is shared with multiple nodes, they could easily flag you being a rogue node and take action. Distributed consensus. The consensus which I just said last slide, point of proof of work, proof of stake, or Byzantine's fault PBFP. So these are the normal salient features of blockchain. We have consensus, it's distributed, it's a digital ledger, it's decentralized, transparent, privacy, secure, audit, etc., etc. Now, Bitcoin, as you have seen, is a public network. Any person can download the software and start running his own node. However, for enterprise systems, we cannot do that. Just like a person cannot walk into an Infosys or TCS website, TCS office and start making changes. You have to be an employee of the Infi, get your role for yourself, and what all activities you can do inside Infi is handled by the privileges for that role. So that is handled in permission and permissionless blockchains. And similarly, in the public and private blockchain, public blockchains are available for every individual, and private blockchains are available for restricted people, like if you are staff of Infi or Wipro, you can go log into the Wipro's network and start working. Right. Public blockchains. Bitcoin is the example of public blockchain, while private one, just like you have a blockchain in your college or your Infosys lab, that's your private network. Even if a block is public, it can be permissioned. Okay, though because the amount of roles that you can do is limited in that approach. Now, what if I am having a non-permission? And non-permission means you don't have to worry about permissions. You have all rights just like any other nodes. So this is a small matrix which I try to put up. Sorry, the slides are a bit old. What is a network which is a public but non-permissioned? Easiest example is Bitcoin. What's a network which is public but permissioned? The Ripple is permissioned. Example of the Ripple is meant for payment between two individuals. So how can we have a private and non-permissioned blockchain? Assuming you run a small blockchain in your college or your Infosys office or lab, that's a multi-chain. What is a private and permissioned? It's a typical examples are like let's say Reliance is running a big blockchain network in India. It's not to say Reliance does have a blockchain network in India. So those would be an example of private and permission network. These are the few aspects of private network. It's handled by a single entity or organizations. You know, people, they are trusted participant. Access is restricted, centralized. There is some amount of centralization because you allowed for people to participate. Consensus is POW, POS, or the variations. POW and POS is no longer used. It's going to be PBFT or WAFT. Now, I have spoken of blockchain for the last 10 minutes. So what I really need to speak is, let's say I have a blog of my own, personal blog. I write about my views on current political scenarios. I don't like the president. I don't like the prime minister. I like the food that I had. I like the finance minister, etc. So can that be made into a block? Yes, I can write a blockchain for that. But then, does it really make sense if it is a blockchain? Do you need to store a state? No, I only write it. So then don't use the blockchain. Are there multiple writers? No, I am the only one who's writing. So don't use the blockchain. Can you use an always online trusted third party? If there is a trusted third party, you don't need blockchain. Okay, then the question comes is, are all writers known to you? No. Then it is a permissionless blockchain. There is no permission needed. So especially the Bitcoin is the example of this. Then the next question is, are all writers trusted? If it is yes, don't need a blockchain. If all need, there is no thing. If a public verifiability required, yes, it's a public RCC and it is permission thing. And if a public verifiability is not needed, we call it as private and permission blockchain. The point is, let's say I am running a fundraiser for one particular event where one person is down because of some reasons, and we need to raise some 15 lakh rupees. I ran this fundraiser, and if we achieve 15 lakh rupees, we'll take that money and give it to that person's account. If we are unable to reach those 15 lakh rupees, the money should automatically be reversed and given back to the individual donors who contributed. This is an example of public permission blockchain, because it's permission in the sense only few people who actually contributed will be given this network. But it is public because each transaction is up for scrutiny, or you could see it. So when he says that, okay, I reached only for 14 lakh and 20,000, and every transaction that was done is seen, and because of which the transactions could not be proceeded, and I'm giving back the money. Now, what exactly is a private and permissioned blockchain? Assuming that we have a big network in India called the GST network. Today, it's not based on blockchain, but assuming that tomorrow it moves to a blockchain network, then what happens? Yes, each transaction that I, as a shopkeeper, as a salesman does, needs to be given to me and to my suppliers only. So such informations can be available in the private and permissioned blockchain. So these are the few examples of whether I should use a blockchain and what form of blockchains are being used. Okay, in industry we have the happening thing. One of the happening things for a blockchain is Hyperledger. I personally follow Hyperledger to some extent. The Hyperledger has lots of tools, and I especially follow Hyperledger Fabric because that's where I learned. So people who are new to blockchain and wants to grab this underlying technology, you could start with Hyperledger Fabric, and based on their use cases and need, they could go to Hyperledger Aries or Burrow, or they could go for Grid. The Grid is specifically for supply chain activities. And the other important thing is Hyperledger Ursa. Ursa is the cryptographic solution for Hyperledger. As we saw that a lot of activities are running based on cryptography. Ursa is one software block or the group that takes care of the cryptography part. These are the various three nodes in Hyperledger Fabric. There is an endorser node, there is a committer node, there is an orderer node. So when you set up a Hyperledger network, let's say the insurance company of India, that is United India Insurance, they have a node. So the clients are the agents, they would submit a transaction, and these transactions needs to be published. So a transaction, what they do is they would submit their transaction, somebody has to endorse it, and once an endorsement is an orderer would pick up the transactions which have been endorsed and group that for a block, and that order will go for to be validated. Once the orderer picks up the transactions for a block, and if they are validated, it is advised to all blocks that this is your next block and these transactions have been approved. So there are clear 3 roles that are needed in this Hyperledger fabric. So this is the classic case of a private and permissioned blockchain. That is, it's private because only the employees or the agents of the United India Insurance can use it, and the roles that they could do is limited. I told you about Hyperledger fabric. It should be fabric. So you submit the transactions here one by one. You will check whether it's endorsing is there. If it is there, it is submitted for an ordering. The ordering service will pick up the use case and give it approved. Once the use cases are approved, it will go to all the nodes. That's what we see here. All peers will going to have the transactions. Okay, this is the new use case. Okay, then there is no questions. Let me ask you a question. What is an identity when you are using a software? Let's say your Gmail or any other mail provider or your Cura. Please answers, please. How do you handle the identity part? Oh, okay. Sorry, Suresh. The blocks. I hope, Suresh. I think you have seen the blocks in the blockchain. Would you like to say that once more? Yes, Suresh. So what we are saying is the block and blockchain consists of two words, block and a chain. So few transactions, few requests to the software system is grouped, clubbed and put it into a block. That's what I'm seeing here. Each of this content is a block. So 1, 2, 3, 4, that would be n number of transactions. These transactions would have their own date, timestamp, login as well, and a current time, and a hash for the same is computed and kept here. This is the minimum needed for one block. This block is linked to another block that using the chain. That chain is the previous hash will be available here. That's what we meant by blockchains. Suresh, are you happy with the answer or you want further questions? Thank you, Suresh. Okay, Nuruddin is saying not to provide some unique information. Nuruddin, I didn't get the question. Oh yeah, right. This is for.
Hi, Vilash, this is Noor.
Yeah,
the question, right? How can we maintain the identity?
Yeah, correct. Need to provide some unique information. Correct. So suppose you're logging into one website, Udemy. How do you do that? Correct. Right thing. Some unique information. Let us say you log into Udemy. How do you maintain that? Correct. What you do is you log into Udemy and then create a profile page. You write your name as Nuruddin, second name is Masumbai Gari, and your address, your company, your hobbies, your interest. You submit that page and create it there. So most probably that website will use your email as your unique handle. Most of the websites does that. So this is let's say Udemy. Now let's say you go to Cura, another website. You will log in there, create a page for yourself, and repeat most of the things there. What are your interests? Like on what topics you contribute? Taxation, aviation, etc. Software industry. Similarly, Yahoo has a page. There also you can create a profile. They would and your interest. So basically, what I'm trying to say here is, at each of these websites, you are giving your personal information there. What is your name, date of birth, your email, your location, your address, and most of the information related to from your cache are being collected by these third-party systems. So I hope that's what happens today. Okay, right. Thank you, Noor. Okay, fine. So that's how it happens today. So an individual's personal data is being transferred to another website. So that's problem for us. let's say you must have heard of that Air India hack. Somebody logged into the Air India website and pulled list of all its customers, or phone pay, or I don't know whether it's MobiKwik or phone pay, just one. Yeah, correct. Isn't it a security threat? Yes, correct. It is a security threat. That's what is being I'm trying to speak. So like PhonePe or MobiKwik, they lost most of their customers' data. What else is there? Transactions. Similarly, the which is that I think that's Barclays Bank also had attack, and where a lot of customer data was available. So that is security threat. Now there is another set of people who take your own data and give it to someone else, especially the Facebook. So when I log into Facebook, I have a unique username, which is my email, password. I have a profile page, and then I upload my pictures. Then using those pictures, Facebook is making money, and they're based on the pages that I browse. Facebook is able to tell what I am looking for, and they are selling this information to somebody else. And those people are coming and contacting me. So the bottom line is, in today's identity, the individual's identity is no longer there with the individual, but we have already given it to some company. Let us see how we can reduce that. So in these systems that we are seeing, there is no control of I'm running the presentation mode. So in these systems, we do not have the control of our own data. And so this is, I'm bringing you the 3 stages. As an individual, you are logging into one website, creating a profile page with the username and password. And after that, you can happily browse the website and continue with that. Then little later, there were too many websites being happened, and you are advised to use a password which is stronger, which people could not guess. And there was another point that, okay, you should change the password at frequently. Today, the banks ask me to do my passwords change, but other sites, few of them use, only few of them helps me to ask me to do it. So what happens is, this system was improved a little, saying there are too many websites. Then an individual has to give their website information at few places like Google, Facebook, etc. And other organizations will pull info from the identity provider. This is the federated identity model, where like Udemy or some other site, either you could log in with your own username password, or you could use a Google ID. So those guys are here. So even though it's a Google which is helping others, but your details are not with you. Your details are with this guy. So with distributed identity, we are trying to help people as an individual that they will have their own public key. This public key would be available on distributed ledger, which they can show it to any peer, and they can control the information. So this is how the mechanism has to work. Okay, one moment. I'm just trying to hide this chat box. This is called self-sovereign identity. That is, self means it's for me only. Sovereign means people who can take care of their own rules. You don't have to keep bother about others. So an identity which is for me, which I will have complete control, and that is being achieved here. You remember, in not in this world, not in the cyberspace, but in real world. If a person comes up and says, I am from income tax, what he will do is he will have his identity card, he will show that to the shopkeeper only once straight and say yes. And then he will keep that identity card back to his pocket. Similarly, if you want to log in, you don't have to produce an identity card everywhere and give it to any person. What happens is a person will give an ID card an identity is provided by an issuer, and the owner of the identity can show it at many places and without even giving up their personal information to other guy. So for that we have a DID, which is a standard based GUI. It's a DID. It's a standard based on GUUID. That is, UUID is a unique identifier. They will use mechanism called as pairwise unique pseudonym. Each time this person is going into a shop, into a website shop to purchase a car, clothes, or an airline ticket, or let's say news channels, he does not have to produce his actual ID. He will be producing a pseudonym. That is a combination. Can we expect? Sorry, right. Can we expect fully secure? Sorry, what was the question? Can we expect fully secure? How to see chat?
So I'll help you with that, Abhilash. Can we
Sure.
expect fully secured error-proof blockchain techniques in nearest future is the question by Vishnu.
Okay. Can we expect error-proof?
Fully secure error-proof blockchain.
Yeah. Okay. Let me I'm happy to tell you that. I'm happy to tell you, till now the blockchain has not been breached. Even the Bitcoin has not been broken. So as of now, it's secure. So there are a few more blockchains which are like which comes from other places. There are few blockchains like the Hyperledger, the Ethereum. They are having cryptography which is stronger than the Bitcoin, and they won't be broken till now. So error, I do not believe there is an error till somebody creates a malicious intent. As of now, softwares in blockchain is open source based and they are not having errors. So I hope that answers the question. Then there is an SSI. So what we're doing is here we have DID, and each time a user produces the DID, a different combination of ID is produced. It's based on its zero knowledge proof, and it is based on a pairwise pseudonym, and it is available for verifiable credentials. So what the important thing is, as I gave you that example, that a person walks in the shop and says, "Hi, I am Inspector from CBI." He will have one identity, whether he goes to shop A, shop B, shop C. However, with SSI, he can go to shop A. His UUID will be unique for that instance only. He goes to another point, he will get another unique ID. That is pairwise unique pseudonym. I think there was one more question. If you would help me, please. Yeah. So, is there any questions? I'm through with the slides.
Thank you so much, Abhilash. I think that was an informative session. Most of our audience are very much engaging to the session. There's one last question. We are almost done with the time. We are about 1 minute exceeding to the time, but let's take this final question and we will close the session. So the question is, what are the skills required? We want to shift your career to blockchain. If we want to shift career to blockchain, that is non-technical or middle management level.
Honestly, for a non-technical person, testing is a happening thing. Testing or the idea is to move to something like a solution architect or a business analyst. However, to reach to that point, you should know the blockchain, the nuances of blockchain, and what terminologies that they are using. So there is no straightaway jump. Pick up some 1 or 2 testing project, and then you apply as a business analyst. That would help you here. In the mid management level, honestly, there is a challenge for people to get into blockchain because blockchain itself is not having many projects in India, at least. Few projects here and there are there, but hopefully in the next 6 months, the POCs that are happening in mostly in India as well as in abroad, they will be running a full blockchain. So maybe next 6 months, yeah, that is now by January or Feb or March, we can expect new openings in blockchain.
Yes. Thank you so much, Abhilash, for answering the question, and thank you so much for a wonderful session on blockchain. I think most
Right.
of our audience had a lot of takeaways from this session, and you have covered almost all the industries. How are they using the blockchain, and how is it going to be in future as well? A lot of questions were answered. Thank you once again on behalf of Agile Network India.